6.8, further exploration with quadratic equations. Okay, well, let's take a look at this then. So we've seen this before, so exploration with quadratic equations. Last time we saw equations with quadratics, and of course we're saying it's a zero factor property where you just take the two factors, and if you can make each factor equal 0 because they're going to have variables with them, then you can find two or more values of x. In most cases, that would give you an equal sign that's a true statement, right? So again, you know, if like A was x minus 5 and B was x plus 4, and you said, hey, this is equal to 0, then you could solve for x from those two factors, because you could say, well, I know now that if I could just get x minus 5 to equal 0, then I could get a true statement. Or if I could get x plus 4 to equal 0, that also would give me a true statement. And then you would find that x equals 5 and x equals negative 4, both of which would give you whatever you started with as true, as the equal sign would be a true statement there, okay? So yeah, sometimes A and B are polynomials, and if they're bigger than that, like a trinomial that you can factor, then do factor it, and that's good too, okay? So as we saw last time, we kind of have to think of all the different factoring strategies that we have when solving these types of problems. Of course, today, it really is just applications of solving quadratics, which may seem kind of weird, but hopefully they're a little bit direct on these, all right? So for something like this, solving polynomial equations by factoring, yeah, make sure we have it in standard form, where you have something that equals 0. And again, we talked about this last time, but if it does not equal 0, you got to use principles of equality to make it equal 0. And once you get it to equal 0, then you can start factoring that polynomial, which is the second step there. You factor the polynomial, factor out any greatest common factors if you can. Sometimes you can factor out an x. And usually if you do, it usually means that the x could be 0. And be careful on that, because sometimes students forget that too, which we talked about last time. Set each factor containing a variable equal to 0, which would include the individual x, but also, like we saw on that last slide, sometimes it's a binomial that equals 0. And then solve the resulting equations, making each factor equal to 0. You just solve them and then check each solution in the original equation, because it is possible that sometimes not all values will work. For now, if I remember right, they do, but every once in a while you'll go back and be like, oh, you try it out, and this is especially true with square root type equations, which we haven't really seen yet, and you probably won't see until 1010 anyways, but just check them anyways. It's a good habit to get into, checking the solutions to the equations you get. So yeah, this one, the length of a rectangular pitcher is 4 times as long as the width. If the area of the pitcher is 324 square inches, find the length and width of the pitcher. So we got to think in terms of rectangles on this one, okay? And sometimes it does help to have, you know, like a picture of a rectangle like this one. Now, if we had a rectangle, no matter how big it is, and this is probably not proportional to what we're grading, because of course the length is 4 times the width, 4 times as long. And so it's a, look at this one right here. I'm going to call this one the width. And what the heck, let's call this one the length right there. So opposite sides are equal to each other, but we don't actually need to label those, because that would be a perimeter type problem. And this is not asking for a perimeter. It is asking for area though, an area which we know at 324 square inches. So that's good. That's good. We have plenty of information to solve with an equation. We just have to be able to write it down first. So if we go back far enough, we could say, well, look at my area. In a rectangle, the area is found by taking a length and multiplying it by the width. And if you need to see that multiplication symbol right there, then put it in. It doesn't matter. But what do we have? Well, we have some values that we can work with. Okay, for example, the area, we already know, is going to be 324 square inches. Now, maybe you notice the other thing as well. And if you haven't by now, hopefully you do, because now we can see that the length, which we have as that green L, is 4 times as long as the width. So if I want my length, which I do, by the way, it's going to be, it has a relationship to the width, which is 4 times the width, okay? Which means instead of length, I'm going to have 4 times a width. But again, this is representing just the length, which means the width right now is just going to come down as width. So this is pretty convenient. And just what I did right there, though, sometimes that takes students a long time. So if you feel like you're being rushed or like I'm going too fast, you got to tell me. But do understand that it takes some experience sometimes to be like, oh, now I understand what's going on. As you're reading this and doing it on your own, because there's going to be a problem like this on the assignment, you may think, well, it's not going as fast as the way Sal did it. Yeah, that's because we're doing it in front of class, and unfortunately I've done too much math in my life, okay? So this is what we have. Okay, that looks nice. Now what are we going to do? Well, let's actually multiply the length and the width, but the length in terms of the width. So if I were to multiply these two, then I would have 4 times the width, which I'm just going to show as width squared. And this still equals my area, which we have. Well, yeah, I may do this twice. Really just because I'm a nerd and I like this kind of stuff. Let's do this 2 different ways, and then you can decide which way you like the best. Hopefully that's okay. But at this point, what I would like to do is, like we saw on that last slide, or a couple slides ago, is we want this to equal 0. So I don't want that 324 there in black. So what am I going to do? Well, I'm going to subtract it from both sides, zeroing it out on this side. And then I would have 0 equals, well, 4w squared, which is not a like term with this minus 324. So I've got to keep these separated like this, right? And now it looks like we have a binomial. You could say, well, yeah, actually we got a trinomial and do some factoring right there. That's not what I'm going to do, because I notice also that at the very least I can take what I have, those 2 terms, and they're divisible by 2, but not just 2. I can factor out a 4. Yep, very good. So that is what I will do. Let's factor out a 4. Okay, so 4 divided by 4 just leaves me with that w squared. And then 324 divided by 4 would be 81. Very good. Now, if you're thinking that 81 is a random number, it is not, which we should kind of expect to be a perfect square. 81 is a perfect square. Why should we expect that? Because we have a binomial and we have subtraction, which means that we should have expected to see something that's probably going to be the difference of squares, which we do have. We have a w squared, and now we've got an 81 that's also, really, I'm going to rewrite it as, let's write it as 9 squared. Okay, so let's rewrite this just so we can kind of see everything here. And really the minus sign is just showing the difference of squares, which is good. Okay, now this still equals 0. Don't get me wrong. We have to remember that it does equal 0. But at the very least, I can take those 2 bases, and then I can write out 2 binomials, right? That's the difference of squares. You can factor if you'd like, but I would like to skip it just because, well, it's the rule, and hopefully we have this down. Okay, so we're going to take the 2 factors, w and 9, and just kind of fill them in. Oh, look what I did. Put a second plus sign. There should have been a minus right there. Now that would be considered completely factored right there, which is nice. Now we should be careful just in terms of factoring, right? You should always look at your final factored forms and just make sure there's nothing that you could factor out of those. Greatest common factors. And right here I see w plus 9, and the 9 has kind of got me a little worried because it also is a perfect square. But the w is not a perfect square. It's just a w, okay? So if this was a w squared, I would split this one up as well. It's not, so I don't have to worry about it. And that's pretty convenient. But in addition to that, I also shouldn't expect it to be squared in this particular context, because what are we looking for? We're looking for a width and a length in this problem. So by doing this down here, I should have at least one of the two values, okay? So remember what we said. At this point, we're going to say, let's go ahead and take these two factors. Notice I'm not concerned about the 4 because the 4 does not have a variable. So I'm looking at w plus 9, and then I'm going to look at w minus 9. And again, it's kind of like what we looked at with absolute values. We say, well, if I could just get one of these factors here, this factor w plus 9, if I could get this to equal 0, then the original equal sign up here, this one, it should give me a true statement, right? And same with this w minus 9. If I could get this to be 0, then it doesn't matter what's going on in the rest of the factors. I'm multiplying it all by 0, so it's going to give me a final product of 0. So, of course, we go in and start solving these two. This first one would say, go ahead and minus 9 from both sides, and dropping the w, we get w equals now negative 9. And then this one on the right would add 9 to both sides, zeroing out that minus 9, and now the w equals 9. Now, that may seem a little weird for width. Okay, how do we get two answers for width? We did not get two answers for width. We kind of did. But we didn't. What the crap is going on right here? Well, think about this. The width, and this may help us as well. The width is in not square inches. That's our area. So these ones, of course, are going to be in inches. And I'm pretty sure we've talked about this before, but you should not get any lengths that are in the negatives. So this one here on the left, yeah, that's definitely pretty weird, and pretty much we can just kind of cross that out. Yeah, but wouldn't it make the original statement up here true? It will. It will make it true, but in this context, which is important for other applications like word problems, you need to make sure that it makes sense. And I don't know what that would look like, negative 9 inches. Well, it's in the opposite direction. Fair enough, but how does that affect the rectangle? You see what I'm saying? So it seems acceptable to have a positive 9 inches, though, and that should be good. Okay, so let's come back here and just double check. So it'd have 4 times 9 times 9. I can't do that in my head, but my calculator can do it, and we should get 324 right there. So right now, we now know that the width is 9 inches. So this is not complete, though. It's not finished. Why is it not finished? Because it said find the length and the width. Well, we just found the width, not the length. But here's what we know. The length of the rectangular picture is 4 times as long as the width. So if I'd like to find the length, which I do want to find, all I got to do is take 4 and multiply it by the width, which we now know is 9. And we get 36 inches. Inches, not square inches. And again, I'm just going to go to my calculator and type this in. Well, 36 times 9, enter. And yeah, it shows me 324 again. Okay, so now I know that I have a width of 9 inches, and I have a length of 36 inches. That was really fun for me because, I'm a math nerd. But here on the right, let's look at a different way to do this because, unbelievable, there's a different way, right? And we actually don't have to do any factoring at all. All we got to do is use principles of equality on this. So that's what I'm going to do. See, because what I'd like to do from this 4w squared equals 324 is just get the w squared isolated. So the first principle of equality is just to get the coefficient of w squared to be a phantom 1. See, and that's what this does. It now gives me w squared because 4 divided by 4 is 1, And w squared equals, unbelievable, 81. Right? So now we're seeing a pattern. And I may be getting a little ahead of myself, but I'm pretty sure we learned that in this class. If I square root both sides at this point, you'd say w equals, and let's say that we haven't learned it just in case I'm wrong on this. The question up here is what times itself equals 81? Now, hopefully the more obvious answer is 9. But there is a second answer which we already found from the factoring, and that was negative 9. But of course, we now know that negative 9 is no good, so don't use it, okay? And at this point, you would have had the width, which we already found down here. You'd label it in inches, and then to find your length, you'd multiply it by 4, and you'd be good to go right there. Now, I don't know if you like this way better or this way better, but both work, and that's the point. Now, the last thing I'll say on this problem is this one was 4 times as long as it was wide. I don't know that we'll necessarily see some, you could. I forget if on the assignment, if they put something like the length is 5 inches longer than the width, which if it did, the only difference is instead of 4 times w, you'd have like w plus 5. Okay, then when you distribute the w, you'd have a w squared term, and then you'd have a w term. So you'd end up with a trinomial that you then have to factor, okay? We didn't have to do that in this case, but again, I'm forgetting if I saw anything like this on the assignment, but I would have almost expected they would, okay? The product of 2 consecutive integers is 156. Find all such pairs of integers. Find positive set of integers and the negative set of integers. Fair enough. So just like we saw in that last problem, you had like a 9 and a negative 9. That's what it's saying. Try to come up with both if you can, and we'll see if we can. So let's give ourselves some space. Now this takes us back to one of the other sections, and I don't remember which one it is, but we know we're looking for 2 consecutive integers. 2 consecutive integers. Now it's not saying even or odd, which is a slightly different scenario, but also very similar. And for this one, here's what I'm going to do. I'm going to say x. I'm going to use a variable, and I'm going to let it be the smaller number. Now we're only looking for 2, so I only have to go for smaller and bigger. This is the smaller number. Now if they're consecutive integers, the bigger number, which I would want to identify, I'll use purple. So the bigger number, I'm going to express with a expression, okay? Now, unfortunately, I can't just say, well, I guess I could. I could say the bigger number is y. The problem with that is when I try to find the 2 numbers, I've got 2 variables. And once I have 2 variables, you can start solving for many different values that would work for this, which we don't want, okay? So let's get rid of this garbage. What I need to do is write the bigger number in terms of the smaller number. So what is the bigger number's value in relationship to that smaller number? And again, this is where we got to be careful. And remember, what we've already seen, it's 1 more than that smaller number. And that will be true for both the negative and the positive set. Now, if we're good there, we need to go back and say, remember, we're looking for a product, right? So I've got to take the smaller number. So let's write this out a little bit. We got the smaller number, and it's a product. So the relationship to the bigger number, or the operation with the bigger number, is multiply. And then it's going to give me an actual product on this, which we already know. The product is 156. So again, instead of a product, I'm actually going to have a value to replace that with. And this is going to equal the smaller number, which I know I'm just going to put in as an x, multiplied by the bigger number, which is the smaller number, but 1 more. Because if we're okay there, then we can start to distribute. So I've got x times x, which will show us x squared. And then x times 1, which is x. And this equals 156. So like we said, when you're solving quadratic equations like we have right here, or a trinomial equation, we need these to equal 0 so that when we get our factors together, then we know, hey, just set these factors equal to 0, the individual factors. But this one does not equal 0 right now, so we're going to have to take care of that. So going into this, what we need to do is 0 out the 156. So I'll subtract 156 from both sides, which will 0 that out. And then it will equal 0 as planned. Then we will have x squared plus, really 1x, minus 156. And this is going to equal 0. If we're okay, let's continue then. Our leading coefficient is a phantom 1, and that just means that I need to find two factors of 156 that are going to add up to this middle coefficient of a phantom 1 right there. So we'll look at factors of 156. Now, I don't know that I've done a great job of this before, but I just want to set decent expectations here, all right? So we're going to look at factors of 156. Some of you guys are finding these factors pretty easily, and then you say, I already know what it is, the two factors that I'm going to use to add up to 1. But some of you are likely taking a little time. At least experience shows that some students, it just takes a long time to figure out what these are. Just don't be discouraged by it. That's the point, okay? So, for example, 156, really it's a negative 156. Okay, so, but factors of 156, of course, 1 and 156. We don't have to list all of them, but like 2 and 78. Or, 3 works. 3 and 52, and it looks like 4 works as well. 4 and 39. Okay. Now, seeing that 39 means that it's divisible by 13. I believe it's 12 and 13 right there. So my point that I was trying to make is we kind of found those fairly quick. So if it's taking you a while to find those out, to find which factor pair you need, just take your time. Use that calculator. Divide by as many as you can until you find the one that works, okay? But again, that may take some time until you get a decent amount of experience. Now, why am I saying that we already have it? Because we already got 12 and 13. They're going to be opposites, and we need it to add up to this positive 1 over here. So that means, since it's positive, we're going to make the 12 the negative and the 13 the positive, because when I add these together, I get a 1. Okay? Now, you can factor by grouping at this point, but like we've seen before, since the leading coefficient is a phantom 1, there is no need for factoring by grouping, although, you're always welcome to do that. But I'm not going to. Okay, so we're going to say, let's go ahead and look at the two binomials that this creates with the x's. And we see the two factors are going to be negative 12 and also positive 13. And yes, as we had already planned, this does equal 0. And again, that's on purpose so that we can take those two factors and see what we get out of them. Now, we'll have to keep in mind that the final product needs to be positive 156. That's what it says up here, even though when we factored it, we were factoring with the negative 156. So there's a relationship there, and we'll have to keep that in mind. We need a positive value, okay? So let's go ahead and look at these two, starting with this x minus 12. Okay, again, if I could just get that one factor to equal 0, the other factor, I don't care what it is, but at least I would have a product that's 0. So we'll take these, and let's go ahead and add 12 to both sides on this one. Okay, that's going to 0 that out. X then becomes positive 12. Now we'll have to keep in mind that x was the smaller of the two values, and I just got a positive value, so 12 should work. Which means if I am looking at consecutive integers, the next value up would be 13. And if I take 12 and 13 and multiply these two, I do get 156. Just like we saw over here when we found actual factors of 156, which then we kind of determined with the negative value which one was negative. So that gives us a positive set of integers. So of course no decimals, otherwise it'd be really weird. But now we can look at the other factor, which was x plus 13. And again, we're going to set this to equal to 0. It doesn't matter what it does over here, because this factor would be 0, and anything times 0 is going to give us this final product of 0. And now we'll solve this one. So this one will say, let's subtract 13 from both sides, zeroing this out. Now x equals negative 13. Now this may seem a little weird, but negative 13, remember, x is the smaller of the two values. So if I would look at negative consecutive integers, just be careful, because some students say, oh, clearly the next one's negative 14, but it is not negative 14. Besides that, negative 13 times negative 14 does not equal 156. The next one up would have to be negative 12. Okay, so just be careful on those two, because it does happen from time to time that students will get those off just a little bit at least, and we don't want that to happen to you. But now at least we can see the two values, the two sets of values that we can multiply to get the 156 right there. So we have to be able to graph, and we have to be able to graph with squares. Like in this case, this is kind of the basis of everything else that we'll see that has an x squared in it. If you can take this graph and then start working around with other trinomials or quadratics, if you will, really just x squared type equations, then you'll see that it's just an adjustment of this one, okay? So y equals x squared is our equation. So remember, the x comes from an x in an ordered pair. So this table right here is going to give us ordered pairs that then we can put on the graph. Looks like they're asking for 5 values. I don't know what they're going to ask for on the assignment, but they didn't give us any values to work with, so we're going to have to choose our own, all right? And the y value also represents the y value from the ordered pairs, okay? So the ordered pair should make the equal sign a true statement based on the values that you get. Now, if I haven't said this already, I highly recommend choosing easy values to work with, such as zeros and ones. The question is, which of the two values should we plug into, x or y? And to make that determination, you just have to look and see where the operations are being applied. So here I can see the x is being applied with a exponent of 2. So that means I wouldn't want to guess y values and then trying to find the x value, because that's going to suck, taking that square and saying, well, what times itself is 3? Of course, there's ways to do that, but graphing that number also is not going to be very fun. So that means I'm going to be choosing x values, and again, just choose values that are like 0, zeros and ones, okay? Why did I put that there? I'll show you. But that means that I'm going to go back to the equation, the original equation, y equals x squared, and I just chose an x that is 0. Well, 0 squared, 0 times 0 is still 0, which gives us the origin at 0, 0. So again, this is an ordered pair. And once again, the idea is that if you were to take the x and y value and replace them into this equation, the equal sign is true. Okay, so x and y's, 0, 0 is right at the origin. Let's see if we can put this in there decently. There we go. 0, 0, and I got it labeled. That looks nice. Well, that's just the point on the graph, but let's work with some other fairly easy values, okay? And we'll change the color just so we know what we're working with. And so I'm choosing an x value that's 1, because 1 is a very easy number to work with. Y equals now x squared, but the x we're going to replace with 1, which is really 1 times 1, so y equals 1. And now we have a new ordered pair, 1, 1, which on the graph is right here. In the past, when we graphed straight lines, that was good enough. And you could pretty much draw a straight line from there on the assignment. That's all you would need. And for today's assignment, that's pretty much all you need as well. Okay, but Let's continue because I'm probably having more fun than I should. Okay, so let's try another value like 2. And let's test this out. So again, the equation is y equals x squared, but we're going to replace the x with 2 squared. So 2 times 2 is 4. And now I have a new ordered pair, 2, 4, that I can put on the graph. 2, 4, 2, 4, 1, 2, 3, 4, boom. And right there you can see that this is not a linear graph. Now just real quick, I'm going to skip this because it's not actually on the graph, but if you tried 3, you'd get 9. Okay, and we can see with the graph that we have, it doesn't work. Well, it works, it just doesn't fit on the graph, so that's where it would be. What kind of line are we looking at right now? Well, here we go. Let's see if we can do this. That's not bad. Okay, that's what we have right now. But is that all that we have? Because couldn't we just say, well, maybe just, what's going on here on the left? Okay, and with linear equations, we said it's just going to keep the same type of shape, right? Well, what does that mean where it's not linear? Well, it means we need to look it up. So we need to find other values of x that we can test out, such as -1. So again, the equation y equals x squared is what we have. But we're going to replace the x with now -1. And I have purposely put that in parentheses. If you don't and you put that in the calculator, it's going to give you -1 because of the order of operations. Please put it in parentheses because -1 times -1 is +1, okay? Well, haven't we seen that before? Yes, we have. Right there, right? Remember when we said x is 1, then the y was +1? Well, why is x -1 and x is -1, y is +1. That's because it's a negative times a negative, and so we end up with this ordered pair right there, okay? At -1, +1. Now this relationship will remain true for all, this is called a parabola, these types of equations with an x squared that you graph, okay? And we'll expound more on that here in just a second, but let's give us another value. I'm going to go with, since we have -1, let's just go with -2 since things are working out pretty good. And let's do this down here. Again, it's y equals x squared. But now instead of an x, we've chosen an x value to replace it with at -2. And again, it's -2 times -2, which is +4. This will be true for, well, any parabola, okay? So we see some kind of symmetry here with the y's. We have kind of the middle symmetry here at 0 for the y value. And then you got 1, 1, 4, 4. So if this is a 9 up here, if you were, by chance, to try -3, you'd get another +9 right there. Okay, symmetric. And again, that's going to lead into 10-10 stuff. But it's symmetric, which means that it kind of mirrors itself, which I'll show here in a second, okay? So this is -2, 4. And let's see if I can do this one okay. That's not my best, but it's not my worst either, so I'm going to keep it. That's what we get. And that's good enough right there. That's good enough for the graph. If I remember right on the assignment, you have to have this point right here at the very tip of this parabola. That's called a vertex. Not that you need to know that right now. But you just need this point, and then any one of these other 4 points will do. All right? But there's something else that's going on with this graph. And again, I'm getting a little ahead of myself, slightly on purpose though. Just so you can understand what did actually happen. So here, right through this tip, which is called the vertex, is this line, which we would call the axis of symmetry. Again, you don't have to know this stuff, but it may help you out later on. Axis of, oh crap. Axis of axis, nope. Yeah, my bad. Axis of symmetry. Well, symmetry just means if it looks one way on one side, it looks the same way on the other side. And if you look at this fairly closely, you'll see that the first value we got here was 1, 1, right? See how it's 1 away from that axis of symmetry? So if you go in the other direction, you get the other point. It's a mirrored effect with this parabola. Or this other point up here, that's 2 away from that axis of symmetry. So the other point is automatically going to be 2 away in the other direction from the axis of symmetry. Maybe that helps, maybe it doesn't, I don't know. But you decide if it does. It just may give you more points to graph because on the assignment, like I said, if I remember right, you put 1 point on, you put another point, you're good to go. It grabs the rest line for you, but don't expect that on an exam. On an exam, you're probably going to need as many points as you can possibly get so that you can do this. This is the foundational graph for all other x squared graphs, which will produce, again, this is called a parabola. Not that I think you care, but everything else is going to be based on this. Like, for example, think about what would happen if this was a negative x squared. All it does is it flips over, and then you'd have a parabola right here, okay? Or how would you make this so that it's wider, like this? Okay, think about that. Well, then you'd need a fractional coefficient so that it doesn't go up so fast. Or how would you make it skinnier, like this? Well, then you'd have a higher than 1 coefficient right here. Or how would you move it? Maybe how would you move it up, for example? Well, then you'd have to start adding or subtracting values. And then how would you move this left or right? Well, then you'd have a binomial that's squared right here. And again, the binomial thing that I just mentioned is kind of getting ahead of ourselves. But you may see it just by looking at the quadratics, though, okay, or the trinomials that we've been seeing. If you feel like you're struggling with this, that's okay. That's pretty normal. But I do want to remind you that this is what we call plug and chug. Just plug it in, see what comes out. Put it in. We've done that before, right? So as long as you can just plug values in for x, and like we'll see in the next problem, right, there's more to it sometimes than that. Sometimes we like x squared plus 5. Okay, just continue to find x values that you can use, plug them in, and then operate on them, plug and chug, and then find your corresponding y value, find your ordered pairs, and then put it on the graph is really all you need to do. So this one does not give us a table, and that's okay. We'll do as much as we can on this graph, put as much as we can, and for some reason this graph goes up to 10 by 10-ish type graph. But again, the truth is, it doesn't matter. We're really just going to choose our own values, okay? So setting up a table, something like this, where, of course, this will give us ordered pairs with x's and y's, and 5 values is nice, but, if you can find more, that's even better. But that'll give us a good, solid 5 values to work with, okay? Now, once again, you have to ask yourself, which of the 2 variables is being operated on? And all of the operations, as we can see, they're being performed on the x. We got an exponent being performed on the x, and then we have a subtraction being performed on the x as well, okay? So that means, of course, that we're going to be choosing x values instead of y values. And just like we talked about last time, start with easy values. Just start with 0 right here and see what that does. So we'll show the work for each of these. But remember, the equation is y equals x squared minus 2. But we just chose the x to be 0. Now you could technically plug that into the calculator, 0 squared minus 2. If you feel comfortable enough, then maybe you don't need it. 0 times 0 is 0, minus 2 is going to be negative 2. And so now we see a y-intercept that does not go through the origin. Of course, it goes through the y-axis, though. 0, negative 2, which, as we saw in the last example, gives us an ordered pair on the graph right here at 0, negative 2. Let's try another value. Let's just, again, keep things simple as we can. Let's choose x as 1. So we got y equals x squared minus 2. And I just chose an x value that's 1. So 1 times 1 is 1. 1 minus 2 is negative 1. So I got 1, negative 1. And that would be on the graph. 1, negative 1 would be right here. Sorry, that's kind of small. So now that we got 1, let's try 2. Well, that'd give us y equals x squared minus 2. And we'll replace the x with 2. 2 times 2 is 4, minus 2 is 2, so we get 2, 2, which on the graph would be 2, 2, right there. Now, I'm not going to show the work for this, but again, 3 on the last example did not work, but it will work for this one. 3 times 3 is 9, and then minus 2 would be 7, so you end up with this ordered pair at 3, 7. Again, it's not necessary that you show that or do it, but I'm doing it just, I like to put as many points as I can on a graph because it makes my lines more accurate. And you guys have seen, my drawings can suck pretty bad. So the more points I have, the better my drawing is. But maybe you'll disagree, and that's okay too. Forgot to label this one 2, 2, and now we got 3, 7, all right? Now, I don't actually have to do any work for those other points because of the axis of symmetry, but let's say that you don't get the axis of symmetry thing, and that's okay if you don't. Well, if you don't, just keep plugging stuff in. So we'll try another value that is, let's try negative 1 this time. So we know that y equals x squared minus 2, but we'll replace the x with negative 1. So negative 1 times negative 1 is 1, and then minus 2 is another negative 1. So we get this negative 1 right here, and we get this point right there. See if we can clean that up a little bit. And negative 1, negative 1. Now automatically, for the graphs that we're doing, this means that we found this point, this we'll call it a minimum, the lowest point on this parabola, which is good for us because you're going to need it, like I said, I'm pretty sure you're going to need that on the assignment. And with that then, we'll do the next value of x at negative 2. Now again, do I really need to figure out what that is? I don't. I already know it's going to be 2, but why do I know it's going to be 2? It's because it's symmetric, right? We already found the middle point, or the symmetric point, right? 0, negative 2, then we got negative 1, negative 1. So the pattern should stay true at 2, 2. So even up here, again, I'm not going to show the work for this one, but if I chose negative 3, I should automatically get a 7 on this one. Symmetric, okay? But let's show the work for that negative 2. So the y should equal x squared minus 2. But we'll replace the x with negative 2. So negative 2 times negative 2 is 4. 4 minus 2 is 2. And we notice that we get that same value right there. So we'll put that on the graph at negative 2, 2, right here. And then, like we said before, we should get negative 3, 7 right here. Right there. Well, I guess the time has come to put my graph on there, the lines. Not straight lines though, right? Because there's definitely not a straight line. I said it would help. I don't know if that helped. I think mine look better on paper, but I guess you'll never know because this is on a stinking iPad. That's good. That's good. That'll do. Now again, hopefully some of you are noticing we do have this, there's this, well, again, what we call this as axis of symmetry right here in the middle. And so this point, which was 1 to the right, its reflected point or mirrored point is to the left, 1 to the left. And then up here, this point is 2 to the right from that axis of symmetry. So 2 to the left would give us negative 2, 2. And then 3 to the right, so 3 to the left right there as well. It reflects itself. And that's it. Now that was fun because I like doing that kind of stuff. just plugging and chugging all day long. And I noticed that no one fell asleep, which is actually kind of rare. There's a different way to do this, okay? And I forget if I've done this. Have I done this on the calculator yet? With the calculator? Okay. So I'm going to use a calculator, not to graph, because, of course, we can't use graphing calculators in this class. But the calculator will give me this table right here. Yeah, but we had so much fun doing it. That's okay. Let's just give you another tool, all right? So here's what we're going to do. Let's go to the graph. Sorry, not the graph, but the calculator. Let's just make sure that it gives us these values, because it should. It's definitely going to give us those values. Let's look at the button progression on this one. Okay, so look on the right there. That is what we call a table. And you'll never believe, on this TI-30XS multi-view, there is an actual button that says table. Craziness, right? So if you look at towards the top left, right next to clear, so you got clear on the right, to the left it says table. Now mine already has an equation in there, but all we got to do is type in the equation, which is, in this case, x squared. How the crap are we going to put in an x in there? Well, if you look on the bottom left, towards the bottom left, you'll see this button, x, a, b, c, and x, let's see. Oh, sorry, I did that wrong. It's x, but then it says y, z, t, and then a, b, c. That's 7 different variables that you can use, and if you continue to push that x button, it will give you the different variables, which is pretty convenient, if you ask me. I just want an x, so I'm just going to push it once. And we know the equation is x squared. Now, on your screen right now, you should be seeing y equals x. Okay, but again, we got to make this look exactly like it shows up in this equation. So I'm going to make it show x squared. So the squared button, get a button up here, is the x squared button. So it's just one button to the left of 7 on this TI-30XS multi-view. And once you push that button, the x squared will show up. This is looking so great, right? And some of you guys are thinking, I miss doing it the old way. And if you do, that's fine. But because now all you're going to do, you're going to push minus. Now I'm going to specify this one because the minus button is not the negative button, which does get confused sometimes. Minus just looks like this. It's on the right column of buttons. If you look one button to the left of enter is your negative button, which we don't want. This is not a negative. This is a minus operation. And of course, you're going to push 2. After you push those 2, you'll notice on the screen it says x squared minus 2. In fact, it says y equals x squared minus 2. I wasn't doing this when we were doing it, but that's what it shows right there. That is unbelievable, right? And you're now having so much fun compared to what we were doing. Where the crap is the table? Well, all we got to do is tell the calculator, please make the table. And to make the table, all we really need to do is tell the calculator to make it, which means you're going to push enter. Now, when you push enter, here you have a new screen that says start, step, auto, ask, minus x, and then OK. Don't mess around with any of that stuff. Don't worry about it. Start is saying where it's going to start. Mine says 1. I think yours should say 0. I'm going to make it 0. Okay, so I push 0, and then I push enter. So I pushed enter once to get that screen. Again, you should just be able to push enter. Okay, then it goes down to step. We're just going to make it go up by 1s. Now that's the x's, by the way. So I'm going to push enter again. And then it goes down to auto. I don't really care about auto. So I'm going to push enter once again. And then it goes to OK. Yes, it is OK. Thank you very much. So I'm going to push enter one more time. Now what you should be seeing on your screen is this. It says X, and there's this line like this, Y. Right now you're seeing 0, 1, 2, and then negative 2, 1, 2 like this. Unbelievable. It's showing this portion, this portion of the graph, at the table right there, okay? These that you're seeing on your screen are the ordered pairs that we already solved for. And again, some of you guys are like, well, that kind of sucks, Sal. You took all the fun out of doing the plug and chug. Fair enough, but you got another tool to work with, okay? So that's nice. And some of you guys are thinking, it's only showing me 3 values. That kind of sucks. Just scroll up or down, okay? Just use your cursor to move up and down, and you'll see other ordered pairs that you could put on the graph. So I've gone up as far as negative 17,287. That's kind of a big number. It definitely won't fit on my graph. So I would scroll down until I could find values that fit on my graph, right? Well, I've already scrolled down too far. I'm at 979. So do I need all those in my table? I don't. But if I needed them, it'd be nice to have them, okay? So that is how you would use a calculator to, again, you can't graph directly, but it gives you a table to help you graph. And I like it. I like that a lot. Well, let's go ahead and graph this one. And of course, we'll need a table to do that. So I've got an X and a Y. On this one, maybe I can do a better table. Not always, but sometimes. Okay. And let's give ourselves, like I said, I always like to see 5 values in there. 1, 2, 3, 4, 5. That looks pretty good. And, if we can fit another one in there, then so be it. Whatever. Okay, now, it doesn't give us any more as far as I can tell. So we got to choose values. And we're going to choose values of X because everything is being operated onto the X. So we're going to start here in the middle with 0. And then like we've seen, we're going to go to 1 and 2, but then we'll do the opposites of -1 and also -2. But for good measure, I'll just show 3 and -3, even though we don't really need those for this example. But they will fit on the graph. So I'm going to start with 0. And of course, the equation, y equals -x squared. But what are we going to do with the x? We're going to replace it with the x we've chosen, which in this case, in red, is 0. Negative 0 times 0 is going to be 0. So that gives us a origin value at 0, 0. Let's go ahead and put this on the graph. Right there. At 0, 0. Okay, then let's just look at the positive values first, and then we'll go to the negatives. So we're going to say y equals -x squared, but our next value is a positive 1. Now this is positive 1 in parentheses. So again, by the order of operations, you'd have to do 1 times 1 first, which is 1, and then apply the negative. So we end up with a y value that's a -1 right there. So I get an ordered pair of 1, -1, which would be right here. Excuse me. And then we'll work with the x value that's 2. So y equals -x squared. But we'll replace the x with 2 this time. And again, by the order of operations, it's -2 times 2. 2 times 2 is 4. And then apply the negative, gives you a -4 there. So that gives us this ordered pair at 2, -4. Now again, I'm not going to show the work for this, but if we put a 3 in there, we're going to get -9, which would give us this point right there. Okay, so that's our positive values, but again, we want to make sure what's going on the left, so we will, and we'll more plug and check. So y equals -x squared, but this time it is a -1 inside the parentheses. So that's -1 times -1, which is 1, and then apply the negative makes that, well, -1. Another way to look at this is you got 2 negatives here with the exponent, and then you got the extra negative right there. It's 3 negatives. 3 is odd, which would make a negative answer. So we got -1, -1, which is right there. There we go. And again, the 2, what are we going to expect? We should expect to see -4, but let's just double check. So we're going to say, well, y would equal -x squared. but we're choosing to replace the x with the -2. So again, 3 negatives is going to make a negative answer. 2 times 2 times 1 really is going to be 4. So it does check off at -2, -4, which would give us this point at -2, -4. Now, like I said, you don't really need to do this, but -3 would also have -9 up here. There we go, which would give us this point right here. And again, this is just for my own accuracy, but you don't really need to do this. But now that we have those on there, we're ready to graph. So yeah, let's get this drawn on there then. That's okay. I'll try that one again. That's okay. It's not great, but it'll do.